See, the first thing to notice about this question is the coordinates of these points P, Q, O, and R. If it's the curve for y equals cos x plus 1, you should know that this here is the principal axis for it, which is y equal to 1 line, that line. This line happens to be the principal axis of it. And it oscillates about that line. It goes up 1 unit and comes down 1 unit. That is what we will understand from the fact that y equal to 1 happens to be the principal axis for it. So, and another thing given about this curve is it's one complete period. So if it starts from zero, if it starts from zero, you know that one complete curve will be between 0 and 2 pi. So the coordinates of O, P, Q, and R can actually be seen by just that. You know, this is the origin, O. This is 2 pi comma 0. Q is 2 pi comma. The largest value cos x plus 1 will be, it's a 1 unit up, it's 1 unit added to 1. So it's a 2 basically. And this one is going to be 0 comma 2. So that is the first thing you would want to keep in your solution before you go do this question. Okay. And let's see what else. See, I'm going to go try to find out this area, this thing. To find out that area, what I do is I integrate the curve from 0 from here to that point. That point. Well, if the whole thing is a 0 to 2 pi, this one happens to be a pi. So because it's symmetrical, so of course this point is actually dividing the thing. This point is actually dividing 0 to 2 pi right in two halves. So this is definitely a pi comma a 0. So I'm going to go integrate the curve between 0 and pi, 0 and pi, 1 plus cos x. This gives me this area. When I integrate the curve between 0 and pi, this is the area I'm going to get. Well, I'll double that to get this whole thing, this one and this one added, because they're the same. So these two added is what I'm going to find out first. Okay. So let's go. You go 0 to pi, 1 plus cos x dx. Well, that becomes a x plus sine x between 0 and pi. Well, that comes out to be a pi only. Okay. Now, so this area, this one, the curve integrated between 0 and pi comes out to be pi units. Of course, this one will also be pi. So this one and this one added, it's a 2 pi. Okay. So let's name them A. Let's not name them A's. Let's keep them area 1, area 2. Okay. Area 1 and area 2 added. 1 and 2 added is 2 times what we got here, 2 pi. Okay. And I also know that the dimensions of this rectangle I have here, this one, these are 2 here and about and exactly a 2 pi there. So 2 is this length because the y coordinate of this point is a 2 and this point is a 0. So of course this height is a 2 and this length is a 2 pi, 0 to 2 pi. 0 on the x, 2 pi on the x. So this whole length is a 2 pi. So I know that the area of this rectangle is supposed to be 4 pi. So area of the rectangle, it's ORQP. It's a 2 into 2 pi. It's a 4 pi. So once I have area 1 and 2 and the area of the rectangle there, I can find out the area of this thing. And it is the rectangle minus those two added. So area of the cusp, you can call it a cusp, is going to be uh, the rectangle minus 1 and 2 added. Well, that's basically 4 pi minus a 2 pi. It's a total 2 pi. So now we have the area of the cusp, this one, this thing, this thing. It came out to be a 2 pi. Okay. Now what I do is I'll find out the area of this thing. Okay. How? Well, I'll go integrate the curve between this x value, which is a pi by 2, and pi. So I get this area. Okay. So let's see. Integral of 1 plus cos x between pi by 2 and pi. Well, you do that, it comes out to be x plus sine x between pi by 2 and pi. Well, that is pi plus a 0 minus pi by 2 plus a sine of pi by 2. And that comes out to be pi minus pi by 2 minus a 1. And that's pi by 2 minus a 1. That's the area of this thing. Let's call it area number 3. This thing. And of course, this area is the same as 3. Let's call it 4. These two added, so area 3 and 4 added is going to be 2 times of pi by 2 minus a 1. That's a pi minus a 2. Okay. And what about that rectangle there? This rectangle there. Well, I know this is definitely, this point is a pi by 2 comma a 0, and this point is a 3 pi by 2 comma a 0, just by symmetry. If the gap between this point and this point is a pi by 2, of course the gap between this point and this point will also be a pi by 2. So this whole rectangle that you have there, this one, hmm, this one has a height of 1 and a length of this minus that. That's a pi. So let's call that something. We can call it x, y, z, uh, and r maybe. Oh no, let's not put a r. Um, x, y, z, and t. Okay, so that box has a area of area of the rectangle X, Y, Z, T is 1 on the height and pi on the breadth of it. It's a pi. So what is this cusp going to be? This one. This one is going to be the rectangle minus those two, 3 and 4. Okay. So the smaller cusp is going to be the rectangle minus the 3 and 4 added. 3 and 4 added is a pi minus 2. And the area of the rectangle is a pi. So pi minus pi by 2, that comes out to be a 2. So the smaller cusp is 2 and the larger cusp is 2 pi. This whole thing is a 2 pi. Okay. Okay. So there's one thing given about these areas that we are going to use now. It's given that the area A by B is a 1 by K, which means B is a K times A. Well, I know that the larger cusp is a 2 pi and it is equal to A plus B. And I also know that the A thing, the smaller cusp, is a 2. So 2 plus K times A is a 2 pi. And B is a Ka. So 2 plus 2K, A is a 2. So 2 plus 2K is a pi, which means 2 common out. 1 plus K is a 2 pi. And that's how you know K plus 1 is a pi and K is a pi minus 1. So that is your complete solution of the question. There. Okay. So the idea was to find out 1 and 2, remove them from the larger rectangle to get this whole thing. And then to find out 3 and 4, remove them from the smaller rectangle to get this thing. The whole cusp came out to be 2 pi. The smaller one came out to be 2. And now you know that the ratio between area A and B is a 1 by K, which means B is a Ka. So A plus B, that is the whole cusp, it's a 2 pi. So 2 plus K into 2, and that's how K comes out to be pi minus 1. You take a screenshot and try to understand. There are major 3 parts to this question. Okay, so that was it.